Hello and welcome in video lecture series Demystifying Blockchain. In today's video, we will see the working of blockchain. Since we have the basic understanding of what is blockchain and we have seen also the cryptography behind blockchain, now I think is the perfect time to look at whole of the working of blockchain. We will start from the hash, then we will proceed towards block, then we will see how blocks are connected to form blockchain, then we will look at the properties of blockchain, that is it is distributed, then we will see what actually goes into the block, right? Then we will see how blockchain guarantees immutability with the help of cryptographic hash functions. All right, so let us start. First we will look at hash. So we have seen this hash function in our cryptography video. So the hash function simply is like if you have some data and you get a unique hash for that, and same time if you try to pass on the same message, if you just try to modify it with a small modification, still you will get completely different hash value. So we have seen this, so it's better to go towards block. So how block looks like, right? This is the block. So block has block number, nonce, data, hash of the block. Now you have to understand what is this mine function. This is regarding the proof of work consensus mechanism. So here I am just giving a brief overview of it, but we will have a separate video in Bitcoin series where we will look how proof of work works, and we will try to see our own program written in Python to dig deep into this proof of work, right? So proof of work is basically you try to hash, right? You try to get a hash of a block that is less than or equal to certain target. What does that mean? You want to find a hash of a block, you want to find a block whose hash is less than certain value. And how would you just get that? If you have the data inside a block, if you try to hash it, you will get hash value, right? If you try to hash again with the same contents, you will get the same hash. But that's why we need to have some variable part inside block so that we will get a different hash value. So for that we have this nonce value. We need to just change this nonce value in order to change the hash value of the block. Once that hash value is less than the target, we will consider this as a valid block, right? For simplicity, let us assume that you have the target that the hash value of a block starts with certain number of zeros. Okay, so once our hash value of the block is less than that target, we will consider our block as valid. So we will say we have successfully mined the block. Now if you look at this, if I change this nonce value, and you will see the color goes to more like pink, right? But if you try to hit mine, soon this hash goes less than the target hash, it will be green again. So you see, you can consider that if your block starts with 4 zeros, the block will be considered as valid, right? So why this 4 zeros? Because the more the number of zeros, the lesser is the value, right? If you look at simple example, okay, so let us take a simple example of 3 bits. Okay, 3 bits. So highest value inside 3 bits could be, like if we take this in binary, either it could be 0 or 1, this could be 0 or 1, this could be 0 or 1. The highest value will be if we have 1 at all places. Okay, so that is equivalent to 7. So if I say, if we start with maximum number of zeros, what could be the minimum value of 3 bits? Like it is 0 0 0, right? If I say it starts with only single 0 at MSB, that is most significant bit, the rest follows this, it's equivalent to 3. If I just hit like it starts with the 2 zeros, what is the value? It's 1. The more than zeros at start, the lesser is the value. So here we have seen that if our hash value of a block starts with 4 zeros, then we consider it as a valid block. But if it starts like with 5 zeros, 6 zeros, and it goes to the maximum zeros, then still the block is valid, because the more the zeros at starting positions, like at MSBs, so the lesser is the value, right? So the target is basically the hash value, hash value of block, it should be less than the target. For this video and for this example, we are seeing that our target should, our target is that our hash value of the block should start with 4 zeros. Okay, so whenever you hit this in Bitcoin series, we will see it in deep detail. We'll see how this makes sense, right? So for this, it's like, this you have to come up with a hash value that starts with 4 zeros. So for this, you have to change the variable called as nonce, right? Okay, nonce, because if you have a static fields inside block, then you will come up with a single hash value, because every time you try to hash the block content, you will get single hash value. But if you suppose first time it was nonce was 0, you get hash value h1. If nonce has incremented by 1, so this will be h2. So that's why we are able to find different hash values. Once that hash value is less than the target, like it starts with 4 zeros, we consider the block is successfully mined. For this examples, it is sufficient, but for Bitcoin series, we will look into deep details. We will see our own program written in Python to look at inner workings of this proof of work. Bear in the mind that we are dealing in hexadecimal, right? Because we see hash function is 256 bits, but they are represented with the hexadecimals like A, B, 0, 1, 7, 6, just like that up to F, right? We can use from 0 to F. But if we look at this value, if these zeros are in hexadecimal, then E0 is basically 4 bits, right? Because every character is a nibble, so we have 4 bits, 4 bits, 4 bits. That is, every single 0 in hexadecimal is basically 4 zeros in this in binary, right? So these are basically 16 zeros. 4 zeros in hexadecimal, they will represent 16 zeros in binary, right? Okay, coming back to this demo, now we have seen that if we try to find some nonce, like this again becomes invalid because this does not start with 4 zeros, right? If we try to hit this mine, what it actually does, this mine button does, it increments this nonce. Once this starts with 4 zeros, this will be green again, right? Let us look at this example again. Here we go, and this is the value where the hash goes to this, right? So this is not the only information in Bitcoin in particular. There are other things inside the block header that we are using for calculating the hash. We will look into this in Bitcoin series, right? So now we understood what is hash, what is block. We will go to blockchain. Okay, so blockchain is what we have seen in our first video, that blockchain, it's just like a series of blocks connected to each other through a special link called as hash pointer, where a block is connected to its previous block, right? If you look at block number 2, it is connected to its previous block through a link called as hash pointer. If you look at this previous hash, this hash should be equivalent to this hash, right? Have a look here. If you look here, we have 7 CF and we have 7 CF. So same goes with the third block. The third block should have previous block as hash of block 2. If we look at block 2's hash, it is C19, and if we look at previous hash in block 3, it is C19, right? The same goes with the other blocks as well. If we look at that, now we have also seen that immutable property of blockchain. So why is it more special compared to other data structures like linked list or all sort of distributed, all sort of things we have in computer science, right? Just because we have this special connectivity between those blocks through hash pointers. Now let us suppose that you try to modify unnecessary stuff here. This block is invalid now because it does not start with 4 zeros, right? Correct. But this hash value changed, right? So this hash value changed, and we have a link that we we have pointer that is written in the second block. Now this also changes, right? So this makes block number 2 as invalid, and same goes with the rest of the blocks. So whole chain is broken now. So that's the beauty. Now if you want to modify, if you want to hack this blockchain at particular node, right, at particular computer, then you need to mine it again. Once you mine it, then you need to mine all the rest of the blocks. So how hard it is? It is extremely, difficult, or you can say it's computationally infeasible to do that, because rest of the nodes in the network are honest and they work according to the protocol, right? So you have to mine in order to make this valid. So this is about connectivity in block. So when we connect blocks with each other through a special link called as hash pointer, we get a blockchain. Now we have to see other feature of this blockchain, because we have seen this is decentralized just because there is no single point of control, right? The control is distributed. Also the data is distributed. If we look at distributed thing, you will see this consistent state of the ledger. This same very ledger will be replicated over the geographical areas, right? With the at nodes will have the same consistent ledger, right? If you see peer 1, you consider is a node 1, and peer B, the same goes to peer 3, right? If someone tries to modify at node 1, but still we have node 2, node 3, that is peer B and peer C, where we could get the data. So this also gives us one more feature, that is availability. Suppose this peer A goes down and you don't have access to the information that is located at peer A, and if we take the same example in case of centralized model where central server breaks down, you won't be able to access any service from that server, right? But here you could go to peer B and fetch the result, because the same very data is located at peer B as well as peer C. So that is like this distributed property, this replication helps us to achieve availability in blockchain domain, right? Now we need to look what goes inside this data, right? This is, if we take an example of Bitcoin, then there are transactions, right? So in that so taking the same analogy here, if we look at tokens, you will see some transactions, right? Very simple for understanding, because you will see one, some tokens from transfers. These are like token transfers, right, from one account to another account. The same goes here. This is very much like what you will feel in Bitcoin, but everything will make sense once we have all the details of Bitcoin workings, right? How Bitcoin works, how blocks are created, how transactions are done. That we will cover in our Bitcoin series. Here you just need to understand the overall scenario and overall workings of blockchain, right? So this, like, what goes inside the body of a block is basically the transactions, right? So transaction transfers, right, from one account to another account. Now if you look at this, the first block has its previous hash as 0, because this does not refer to any previous block. This is a starting block, but the second block will have previous block as block 1's hash. If you look at this, we have 96p, you will get 96p here, and same goes with all the peers that we have here, right? The same things are there. If you look at the body of block 1 in peer C, this has the same data that is in peer A and peer B, right? Now if we look at the concept of where this come from, right, how you could see this, this Darcy to Bentley has like transfer 25, but how Darcy is able to do that? Because they should have first some balance, right? If you say, okay, how you could prove that Darcy has this 25, there should be some mechanism. If we look at this Coinbase is basically an action that gives rise to new coins. Things will make more sense when we go to the Bitcoin. Just for this example, you have to believe Coinbase is the reward, right? If you are able to successfully mine a block, you will get a reward. And if you look at this is a Coinbase transaction that is generated out of thin air based upon the work that miner has done in mining the block. Let us suppose this Anders has Enders was successful in mining this block, and it has been, this Enders account is being credited with 100. Now Enders has 100 balance, right? In next following blocks you will see some transactions from Enders to all other participants, right? Because Enders have 100 balance, here he is trying to transfer 10, 20, 15 to other participants. Now these participants can make transfers, right? When every block has this Coinbase, right? If you see Coinbase, that is origination of creation of those tokens or coins, right? As part of the reward mechanism inside Bitcoin, if we take an example. So if you look at this, now Imli can do a transaction to Jackson. Why? Because Imli has received some funds from Enders. If you look back again, see, Imli has received 15, and now Imli has transferred 10 to Jackson, right? And Imli has only 5 left now. If Imli tries to send 5 to Madison, then Imli cannot do any transaction because she does not have any balance. So this is like overall working of blockchain, how hashes are being used, how blocks are being created, how blockchain is built with the help of blocks and connected with each other through special links called as hash pointers, then how they are being replicated and distributed over the geographical areas, and how tokens are being used, how token transactions are being recorded and put into the block, and finally we see what is the mechanism of creation of new tokens through a Coinbase transaction. If we take a simple example for Bitcoin, we say these are the mining rewards, the only way to create new Bitcoins in Bitcoin, right? So that's it for this video. If you like the content, hit the like button of YouTube video and do subscribe to the channel for latest videos on Web3 and blockchain world. Thank you.